Well, I thought I would do a few more examples from section 8.2 before you work on that assignment. This first one I wanted to do, number 18, it actually is intended to not use a calculator. We're going to go ahead and use one anyway to create our graph. And actually, our goal here is to kind of understand the concept of how you find the area between two curves. So, and being able to set up the integral. So that's really what I want to focus on in this section. So when you guys are doing the assignment, I don't care if you use Finite on your calculator. I want to see a picture and the integral that you use to get your answer. So on this first one, the first thing you need to do is you want to see what the graphs look like. So if we have x to the fourth minus 4x squared plus 4, and then we're going to graph y equals x squared, except I need to not do that. Okay, try that again. So I'm just going to do Zoom 6 and start with at least that standard viewing window, and I might adjust it a little bit. So I am going to adjust this because I want to be able to just focus on this portion in here. So what I like to do for that one is if you hit Zoom and check that first one, the box, you'll want to move the cursor to start. It needs to be in the top left corner, and then hit enter. And now you're just going to use the arrows. I think on your calculators you can hold it down, but on my digital one I have to keep hitting it until you get this portion that we're going to zoom in on. And we see that a little better. So we can kind of see what's happening here. I think maybe I will cut and paste this so I can write on that. Okay, so I decided to go ahead and make the graph. So, but what I did is I used the table. Y1 was my, the one that was x to the fourth power, and then in Y2 was my parent graph for my parabola. So I just used that to plot some points. Don't really care where the x-intercepts were on the quartic function, but what we need to come up now with the area. And so the area we're looking for is this part here, the enclosed region. So notice that the function that is the higher function, it's going to change. So we actually need 2 or 3 integrals. We do have symmetry on these two sides, so we could just do one integral and then double that. I would probably do that if I was doing it by hand. If I was doing it with Finite, it doesn't really make a big difference. So, so what I would say on this one, I'm going to have the integral, and you would need to know where it changes. So we're integrating. I'm going to do vertical strips for all of these. So these would be vertical strips, and which means I'm going in the x direction because it's dx. So this is -2, and that's where there's a point of intersection right up here. So we're going from -2 to -1. And the one that I have in red, which is my x squared, that's on top. So it's going to be x squared minus, and then don't forget to have parentheses here, dx. And that's the one I'm going to double that because I have two sides, and it's with the symmetry, it's going to be the same area. Then I'm going to add to that the integral, and this goes from -1 to 1. And now the quartic function's on top, so it's going to be x to the fourth minus 4x squared plus 4, and then minus the x squared dx. And this is actually what will tell me the area in between the two curves. I'm going to assume you guys could do that because at this point you could Finite it. You wouldn't even have to simplify. I mean, you could, x squared, you could simplify the expression. If you had to do this one by hand, you could, because the antiderivative of a polynomial function is pretty easy to do with the power rule in reverse. But I just wanted to show you how you use the picture. You're going to have to decide how you set up your integral. If they weren't obvious where the points of intersection were, you might have to do second calc intersect to find what those points are. Very possible that you would need to do that. Okay, so for this next problem, we have x equals y squared and x equals y plus 2. Now, if you were going to try and graph these, we have the issue that our calculator wants it to be y equals. So you have to, if you're going to use your calculator to graph, and you can, you just have to kind of think this through. So for example, I could switch this to y equals plus or minus the square root of x, and I could switch this to y equals x minus 2. Now, this one graphing on your calculator, because it is a parabola on its side, and you have to do it in two pieces if you're going to graph it on your calculator. So you'd have to do the square root of x, and then we would have to do negative, or the opposite, of the square root of x. And now we can graph this other that would be a line, x minus 2. So now if I graph those, I'm going to go back to my normal standard viewing window. Okay, so this is what the picture looks like that I'm interested in finding out. So, I mean, you could do a sketch, that's fine. So if we just kind of go through and sketch this, and we have this sideways parabola, and we have this line, and we are looking for this region. Okay, so you can see why they gave you these in terms of the y value, you know, in x in terms of y, because it makes the most sense to do a horizontal strip, which means we're using dy. So that means we want it in terms of y. So remember the line, because it's farther, in the values of x are farther, it's the higher one, because it's farther to the right. So this is considered, would be the larger function. So we're going to have, we're going to take the line first. So we're going to have the integral, it has to be in terms of y. So we are going to have to know the limits of integration, but we'll do that in just a minute. So this would be the y plus 2 minus y squared dy. So there's my function. Now I have to know this y value and this y value. You can do that over here if you go second calc intersect. Okay, so I want to know if I'm going to do this one. Okay, so there I'm on the top part, so I can click that, and then it wants to know the second. That's not the curve I want to be on, so I want to be on the line. So I'm going to hit enter, and then I can just put guess there. So 2 is the y value. So this point is 4, 2. So my upper limit is a 2. And then I want second calc intersect. And now I need this one here. So I'm going to hit enter. And then I want the line, which I'm on. And I get 1, negative 1 is this point. So the y value would be a negative 1. So this is my integral that I would want to evaluate, and that would tell me the area in between the two curves. I'm leaving that. I figure you guys can do that. I would want your answer, so use your calculator and finite it, but I know you guys know how to do that. Okay, next one we have y equals 2 sine x and y equals sine 2x. And I know you might be panicked, except we're using our calculator, so we can graph these, and they do give us on this one we have the domain, so we're going to have to plug that into our window. So we're going to start. You want to make sure your calculator is in radians. I know mine is, but you might want to check yours if you've been using it for using trig and in physics at all. And then we have sine 2x. Okay, so there's my two functions. Before I graph this, I want to go to the window, and I want to put in for x 0, and the max is pi. And because I know that sine x is between negative 1 and 1, then that means 2 sine x has to be between negative 2 and 2, and sine 2x is going to be between negative 1 and 1. So the reason I'm thinking of that is this y value, I'm going to make -3, and my y max, I'm going to make 3 because I know that it's not going to be higher than that. And that way I can get a little better picture of my graph. All right, so we are trying to find the area of this. Okay. Oops. So you can kind of tell from looking at this that it makes sense to do vertical strips. However, this one is a little complicated. Actually, no, it's not. Because all we have to do, because it doesn't ever change. So this top curve, which was y equals 2 sine x, so that was this one, and then the other one was sine 2x. So when we do the integral, and we're actually doing a vertical strip, so it's dx, which means everything's in terms of x. So I'm going to take 2 sine x minus sine 2x dx. And we're going from, this was 0 and this was pi, so from 0 to pi. And that's all you have to do. And then you can use finint on your calculator to do that. So really, that one's not bad at all. Number 36, which I put a note there that it is a no calculator problem. So, I just kind of want to talk about how you could do that without your calculator. Let me set this up better though. So as far as getting the graph of this, this is just, notice that this is the same as having y equals -x squared plus 4. So it's just the parent graph reflected over the x-axis and then raised up 4. So that means the vertex, instead of at 0, 0, it's going to be up here, and then it's going to open down. So we end up with this. And then we have our line, y equals 3x. So we know that goes through 0, 0, has a slope of 3. So we get this line. Okay, so looking back, looking at what this is asking me to do, once I kind of have my graph, find the area of the region on or above the x-axis bounded by these curves. So I have to think about what region I'm looking for. So I need it above the x-axis, but in between the two curves. So it's actually this portion right here, because it has to be above the x-axis. So if it was actually just in between the two curves, then I would be taking just the parabola and subtracting the line. But I don't want this down here. I only want this that's up here. So if I were to integrate, if I did the integral from, I am going to do vertical strips. So it's going to be in terms of dx. So if I go from -2 to 1, of this upside down parabola, so the 4 minus x squared dx. Think about what that would give me. That would give me that would actually give me additional that I don't want, because that would give me all of this. That would give me this piece as well. If I just go from -2 to 1, it gives me everything underneath what I have in red, that function, between underneath that and the x-axis. So I would have this extra little triangle piece. Well, I need to get rid of that. I need to subtract that because I don't want that in my answer. I want just the part that I have shaded in green. So I could do that a couple ways. For one thing, I can look at it and say, well, that's just a triangle. So I could just find the area of the triangle and subtract it and use geometry. And you could do that because you have 3 times 1 divided by 2, so it's going to be 3 halves. Or I could integrate, I could subtract the integral from 0 to 1 of my function 3x dx, which would just give you that area of the triangle. So, sometimes you have problems where it's not just a straightforward, subtract the functions, because they kind of give you some other stipulations on what part of the region you're looking for. So you have to do a little bit of problem solving. And if you fit into this, or you did the antiderivatives, that would give you your answer as well. So hopefully those help you with the problems that you have. And remember, you also could look at examples in your textbook, because there's more good examples there. So let me know if you have any questions on your assignment.